Anta has brought us a new series of mid-range basketball shoes, which is the Anta Magic Cement series of practical basketball shoes. The high-top styling design in Anta Magic Cement basketball shoes looks high-end and atmospheric. Magic Cement features a refreshed midsole cushioning configuration with a snug upper designed to help players achieve fast performance and multi-directional grip, allowing them to shake off the defense while controlling the ball. On the neckline of these shoes, Anta also added a reinforced foam designed to enhance the protection of the user's ankles. Island Space Impact Resistance Stable Midsole. Adopting a new submarine space impact resistance stability midsole technology, made of high elastic foam material and smart, the SAM system breaks up the upgraded formula of refusion to improve midsole stability while reducing the weight of the midsole. Wear-resistant outsole. Anta Cement Buster Formula outsole provides better grip and wear resistance, excellent wear resistance, easy control of outdoor courts, help players change more daring, and help the actual combat experience in the field. The upper is made of woven material and reinforced foam with a neckline to enhance the feeling of wrapping, protect the ankle, improve the tear resistance of the upper, and the cutout details enhance the breathability of the product. Materials like rubber or plastic. Hardness is a measure of how resistant a plastic is to deformation caused by mechanical indentation or abrasion. Engineers can test a material's hardness using a durometer tester. A recent review on basketball footwear concluded that softer midsoles are related to better impact attenuation in unanticipated test scenarios. In step-off landings, shoes with a soft midsole, Asker 40 Shore C or 18 Shore A, were able to better attenuate impacts compared with a regular Asker 55 Shore C or 30 Shore A, and a hard Asker 70 Shore C or 50 Shore A midsole from different drop heights. How to determine the traction of the rubber outsole. We will go back to basic formula of coefficient of friction. Friction occurs in two ways, kinetic and static. Kinetic friction acts on an object that slides across a surface, whereas static friction occurs when friction prevents the object from moving. A simple but effective model for friction is that the force of friction, F, is equal to the product of the normal force, N, and a number called the coefficient of friction, mu. The coefficient is different for every pair of materials that contact each other, including a material that interacts with itself. The normal force is the force perpendicular to the interface between two sliding surfaces, in other words, how hard they push against each other. There is a distinct coefficient of kinetic friction and coefficient of static friction for each scenario. These two types of friction help to describe how an object moves. The formula to calculate the coefficient of friction is mu equals F divided by N. The friction force, F, always acts in the opposite direction of the intended or actual motion, but only parallel to the surface. In colloquial terms, I will show you the values of rubber outsole traction or grip in terms of coefficient of traction. Nominally, good traction for rubber outsole is 0.8. 0.8 and above value is R perfect 10/10. Sliding surface ranges from 0.4 and below. Wood is around 0.25 to 0.5. Rubber-soled shoes on a brushed concrete surface can generate a coefficient of friction of over 1.0. In general, a coefficient of friction of 0.4 to 0.5 is considered a good traction offering. This values will be 5/10. A decibel meter is a measuring instrument used to assess noise or sound levels by measuring sound pressure. Often referred to as a sound pressure level (SPL) meter, decibel dB meter, noise meter or noise dosimeter. A sound level meter uses a microphone to capture sound. What is an acceptable noise level? Generally, exposure to sound levels above 85 decibels is considered damaging to human hearing. That is why this is the most common maximum value allowed in industrial environments. For residential environments, the accepted decibel level is lower. Any noise exceeding 70 decibels is considered disturbing. According to Newton's third law, for every action there is an equal and opposite reaction. When we hit the ball on ground, then in this case there is an equal and opposite force on the ball in the upward direction due to ground Newton's third law, which makes it bounce. Bouncing ball involves a single impact. We call this property rebound resilience, and express it as the ratio of the rebound height to the initial drop height of the ball. We will apply this to the insole and midsole and compute for the reaction or bounce in percentage rate. Note: this is not a resilience test but bounce reaction rate test on the insole and midsole to determine quality of bounce, zoom or other terms used by different manufacturer.